In this video, I'll be discussing about derangement, which is a topic in combinatorics, and I'll try to give an intuitive idea of how this works and how you can understand it intuitively. So, to understand how it actually works, we first need to be clear about how to calculate the areas when dealing with Venn diagrams. Forget about this for a minute. I'll talk about it later. So consider we have three circles. Uh, we have three circles, and I want to find the area of all these three circles, excluding the overlapping. So what I essentially mean is, I'm trying to find the area of a figure like something like this, which is, it will transpose into something like this. So I'm basically trying to get the area of this thing. Now, how do you actually, now consider this is A, consider this circle B, then C, and the area of them is A, B, and C. Now I'm interested in finding the area of this figure. So how do I find it? You'll be like, now just add A plus B plus C, which is the areas of these individual circles, and then subtracting the area where two of them overlap. So this area right here, then where B and C overlap, then this area where A and B overlap, and this area where A and C overlap, which is just A intersection C, and then minus A intersection B, and then minus A intersection no B intersection C. So now is this sufficient for finding this area? Now there's actually a there's actually a blunder in this when we write this, because this will actually not give you this area. Now why is that so? Now when subtracting this area, when we subtracted this A intersection C, like this area, and B C this area, and then A and B this area, we have also subtracted the area where these all three circles combine. We subtracted that area twice. So basically this area is not counted. Now what do I mean by it's not counted in this? So when we first added the area of A, B and C, this area was this area, let's say this was Z. Now when we added the areas of A, B and C individually, this Z area was counted thrice. Z was counted thrice, and when we subtracted the overlapping of two circles, now consider A and C this area, and B and C this area, then C and B this area, we subtracted this Z area thrice. So we subtracted this area thrice. So the net area of this is 0. We actually did not account for this area. So to account for this area, we'll just add Z in this area thing. And this, what is this Z? This Z is actually nothing but the intersection of all these areas. So yeah, this is actually the area of three circles. Now coming back to derangement and understanding how it works, we take the help of Venn diagrams. Now consider the situation I'm going to tell you about. The situation is it's a rainy day outside, so I'll take an example of a rainy day. 5 people come to my house with their umbrellas, and when they're leaving, the umbrellas, their umbrellas will get mismatched. Their umbrellas will get mixed in such a way that no one gets their own umbrella back. So that's essentially what derangement means. So now this figure right here, this this rectangle thing, it's N. This is the universe. This rectangle represents the universe, and it essentially has all the permutations of these 5 umbrellas. Like let the umbrellas be A, B, C, D and E. Now in how many ways I can arrange those 5 umbrellas, which is that's just 5 factorial. So the value of this n is 5 factorial. Now the entire universal set. And what do these circle actually represent? So the circle A here, the circle A, it represents the number of ways in which the umbrella A will go to the person A. And similarly B will represent the number of ways in which umbrella B goes to person B. And basically what derangement is, so the derangement, what we are going to find is just basically the area of this entire set, which is 5 factorial, minus the area of these 5 circles. So D is nothing but n minus the area of these area of these 5 circles. And how do we find the area of these 5 circles? We just calculated for area of 3 circles just right now. So I'll just use the information I have about them. So I know the area of them is going to be, so I'll just first add all of them up. I'll use a simpler, I'll use summation A of I, where I will vary from 1, 2, 3, 4, 5, which will represent different circles, and minus sigma of AI and AJ, where this means taking 2 circles at a time, and then adding for the over counting, which is just sigma AI, sigma AJ and sigma AK. Then again subtracting for over counting again, which is just AI, AJ, AK and AZ, and then adding for the areas I did not add. It just becomes AI, then 5 A's, simply just 5 A's. So now this is going to give me the area. So it's basically just D, which is derangement, is just the universal set, area of universal set, which is 5 factorial, minus area of all these circles, which is this expression right here. Now how do I actually find A? Now I know what A is. I said A was the ways in which the umbrella A will return to person A. Now how do I find how do I find the number of ways in which umbrella A will return to person A? That's just I'll select one umbrella, which is 5 C1, 5 choose 1 times and arranging those different, the remaining 4, the 4, what do you say that, the remaining 4 umbrellas I can just rearrange them. I'll just write 4 factorial. So what this will give me is 120. That's this expression right here. So this is computed for. Now moving on to this, how do I solve for this? I'll just do 5C2 times 3 factorial, which is 60. And similarly, for this one I'll simply do 5C3 times 2 factorial, which I'll get some number here. And for this I'll do 5C4 times 1 factorial, and I'll get this. Then I'll just do for the last one, which is 5C5 times 1 factorial, which is just going to give me 1. And I'll basically get this term, the numerical value of this term. Now all I gotta do now is just, I know what derangement was. Derangement was n minus the area of this, which is going to be some numerical value. Let's just say that's r. So D becomes n minus r. D is 120 minus r, and I can Google the value of D5, which is I know is 44. So D5 is 44. So R I can find by this. That's basically how derangement works. Thank you.